All right, let's look at the convolution property. All right, so it says this. If you look at the Laplace transform of the convolution between f of t and g of t is equal to the Laplace transform of f of t and the Laplace transform of g of t multiplied together, right? So which is the same thing as capital F of s times capital G of s, right? All right, so let's prove this, all right? So first thing is we have to make a little bit of assumption. We're going to assume, let's see, we're going to assume that, f of t and g of t both equal to 0 if t is negative. Right. This would not affect anything because if you when you try to find the Laplace transform, integral always starts from 0, so we never consider the negative part of the function. Right. So we make that assumption there. All right. Then let's look at the left hand side. So left hand side is going to look like this. All right. So we have to take the Laplace transform, right? So it's going to be an integral from 0 to infinity. Then you have e to the negative st. Right? Then we have to take a convolution, so it's going to be another integral from 0 to t. Then you have a f of tau times g of t minus tau. I'm just going through the definition of the convolution here. Right? Then dt. Right? So this is the left hand side, right? So let's look at the right hand side a little bit. I'm going to look at the one by one. So let's look at the capital F of s, right? Right. Since if you look at the left hand side, f is using a variable tau, I'm going to use that too. So it's going to be an integral from 0 to infinity. Right? So this is just a Laplace transform. So you have a e to the negative s. So instead of t, I'm going to use tau, right? Then this is going to be f of tau and a d tau, right? We have that. All right, then we're going to look at the g of s as well. So g of s, right? This one, I'm going to use just a different variable, so I'm going to probably use u or something like that. So it's going to go from 0 to infinity, e to the negative su, g of u du, right? But I'm going to do a little bit of rewriting here, since if you look at the left hand side, and we're trying to match the left hand side, right? So if you look at the left hand side, g has t minus tau inside. So what I'm going to do is I'm going to do a substitution. I'm going to let u be t minus tau. Right, then I'm going to just take the derivative of u with respect to t, which is going to give you 1, and which means that du and the dt are actually the same thing, right? And also we have to do the lower limit and the upper limit. So original variable u goes from 0 to infinity, right? Then if you look at the t, right? So if u is 0, t is going to be actually tau, right? If u is infinity, then t is going to be infinity too, right? So this is going to look like this. So this is going to be integral from, let's see, tau to infinity, right? Then you have a e to the negative s times quantity t minus tau, right? G of t minus tau, right? du is same thing as dt, so we just put dt here, right? And another trick is that here we notice that when t is actually if t is smaller than tau, this t minus tau is going to be negative, in which case g of t is going to be 0 anyway. So instead of starting from some positive number tau, we can start from 0 because it's not going to really add anything. So we can actually change that to starting from 0 instead, which doesn't change anything. Alright? So then we're going to compute the right hand side to see we can match the left hand side. Alright, so let's look at the right hand side. Right? So this is going to be equal to, right? So we have, so f of s is going to be integral from 0 to infinity e to the negative s tau f of tau d tau, right? Then I'm gonna leave a g of s for now as g of s, right? As you can see that the g of s has nothing to do with tau, so what we can do is you can actually, this is just a constant, right? So we can actually place it inside the integral, right? So we're going to have, so you have an integral from 0 to infinity, right? Then you have e to the negative s tau and f of tau, right? So I'm going to put g of s. G of s came out to be integral from 0 to infinity e to the negative s quantity t minus tau, right? And then you have a g of t minus tau dt and a d tau, right? So we have that. Alright, so what we can do here next would be this. If you look at the e to the negative s tau, right, then here you have a e to the positive s tau. Maybe I should write that down. So here, if you split this guy into, let's write it here, e to the negative st, which we're going to keep, but the other one is simply e to the s tau, right, because it's just a double negative, right? Then we have a reciprocal sitting here, so we can either pull this guy out because this is nothing to do with t, or you can put this guy in. Either way, we'll be able to cancel them, each other. So I'm going to cancel this guy with just that guy, right? Then what you get is going to be this. So you have integral from 0 to infinity, right? F of tau has nothing to do with t, it's a constant, so we can put it inside. So I'm going to just put that inside. So you have an integral from 0 to infinity, right? Then we still have e to the negative st, right? And we still have f of tau, and we still have g of t minus tau, and then we have a dt d tau, right? So make sure that we covered everything, right? So you have, we put f of t here, and then you have a g of t minus tau, and we have a dt and d tau. So it looks like we have everything here, right? All right. So the next step is I'm going to switch the order of integration. So I'm going to do d tau first, then dt. So I'm going to just switch those. So I'm going to actually go ahead and do it. So I'm going to scratch those. Then I'm going to put the d tau first and the dt. Right? Since the limits are exactly the same, so even if you switch it, it doesn't really change anything. Right? Then here, if you have a e to the negative st, it has nothing to do with tau. We can place it outside here. All right? So we're going to have integral from 0 to infinity. Then you have a negative e to the negative st is pulled out. Then you have an integral from 0 to infinity, right? And the f of tau, and g of t minus tau and d tau and then dt, right? We're almost there, right? So if you compare this with the left-hand side, and we have everything except for this guy right here. So this is upper limit has to be t, and if we have infinity, right? Can we fix it, right? So here, if you pay attention, and since g is going to be 0 when you plug in negative value, you can see that if tau exceeds t, it's going to be negative. So the g is going to be 0. So if you beyond t, it's not going to give you anything positive. It's going to be always 0. So if you scratch this infinity, then we can actually stop at t, because going beyond that is going to give you 0 anyway, right? So we have that. Then you can see that this is exactly the same expression as the left-hand side. So this is equal to the left-hand side, right? This establishes the convolution property, right? That's it. I hope that this was clear.